Hello, this is Dr. Carr, and I'm going to tell you a little bit about rocks and minerals. So on my screen, you can see there is a big rock in the middle, and this rock is made up of minerals. All these colors you see are from minerals. So a rock is made up of minerals. In igneous rock, we are lucky that there are about 10 minerals that makes up most of igneous rocks, and there are 3,000 or 4,000 minerals. So only a few. And I've dumped these minerals in here, and you can see some of these minerals are you have seen in your minerals lab, and some of them you haven't seen. So the question is, if you want to match these rocks minerals, because minerals, the rock gets its color from the minerals. So I can see there's some pinkish tinge. So this mineral will match up. There are some whitish tinge, so maybe this one will match or this one. So depending on what we see in a big rock, in a plutonic rock, intrusive rock, we can see the minerals. And depends on at what temperature did this rock form and what is its composition. Not all these black minerals are going to be present in this rock. So what we are going to do, and then know that there are three types of feldspars. One is a potassium feldspar, which you have seen in your lab. It's called orthoclase, it's pink. And there is a white feldspar, which is sodium feldspar. And then there is a dark feldspar, which is calcium feldspar. So now let me go to the next diagram, next slide. And you have seen the bounce reaction series. It tells us at how the minerals crystallizes over a period of time and from a crystallizing magma. So you will see that olivine and calcium plagioclase are the highest temperature minerals, and then pyroxene and plagioclase feldspar, and then amphibole, biotite, and these are your dark minerals. And the light minerals are sodium plagioclase, potassium feldspar, muscovite, and quartz. So what I do generally is I take this one and I turn it, because here is my igneous rock diagram. I have magmas and I have plutonic rocks and I have volcanic rocks. So what I'm going to do is I'm going to put the bounce reaction series here, and I'm going to turn this thing so that I can match up my four compositions with so here I am. So I'm going to turn it. So now just look around, like on your side. So you'll be able to see that these are my four things that match with the four types of magma that comes up from the rock. So one's called ultramafic, one is called mafic, these are called intermediate, and these are called felsic, the light colored ones, and the intermediate colored ones, and the dark colored ones, and the light colored ones. Plutonic rocks will have large crystals, volcanic rocks will have small crystals. Now see, the minerals you can see in so this rock is green, this is one of the green rocks. So these I will say has very small crystals, and this is my volcanic one, and this is the other green rock I have. This is my plutonic rock. So now these are green rocks because of the minerals. So what I'm going to do is I'm going to look for those minerals that I had shown you before. I'm going to go and grab them from the other slide. And so you will see that these minerals are present in these rocks to make this rock green in color. So what minerals are green? So olivine is green. And if you see olivine goes in here, so this mineral is present in this rock, both the rocks. One you cannot see because it's very small grained volcanic rock, and the one you can see pretty much because it's a pretty large grained plutonic rock. It's called peridotite. And you will see that these two rocks are green. So these are the minerals that are now the dark rocks, pyroxene and all, plagioclase minerals will be present in the dark rocks, which are, now you look through these minerals, rocks, these are the minerals, and these are your rocks down here. So some of these rocks have large grains, and you will be able to recognize some of these minerals. These are the ones that have large minerals in it. These ones doesn't, like this one has some, and then these ones, these three has large minerals. So these two are dark rock, this one and this one. One has large mineral grains, one doesn't. Now look at this. So if these are the dark rocks, so they will go in here, and they are named gabbro and basalt. But now I can go up and see which minerals will be present in the gabbro and basalt. and they will be mostly pyroxene, plagioclase. You can have a little bit of olivine, maybe a little bit of biotite, or So if I take my minerals, and because you haven't seen all these minerals, that's why you're probably having a little hard time looking at it. So here are my minerals. So all the igneous minerals that we see generally. So if I take these minerals and bring them up to my minerals, on the bounce reaction series, I will be able to place them pretty easily on those minerals. So take a look, they go in pretty nicely. So if I have these minerals here, because you haven't seen this, it's hard to do. This has two cleavages. So this is a pyroxene. This has two cleavages, not at 90 degrees. So this is an amphibole. And you can see this is your white feldspar, which is the plagioclase feldspar sodium. This is your potassium feldspar. So they kind of group in the what direction, and from left to right, your temperature is cooling as this magma is crystallizing these minerals which are forming these rocks. And this is this high, this is one of these biotites, and then you have, um, I missed one of them here. Yeah. So this is your one that has no cleavage, and this is your quartz. So these are your minerals that form the igneous rock. So now you can see which minerals will go and form which rock. So they're pretty easy. But you would not be able to see the minerals in the volcanic rocks. You will be able to see the minerals in the plutonic rocks. So that's what you are looking for. So these minerals are going to be present in this rock. It tells you, the bounce reaction tells you which reaction minerals will be formed in which rocks. So these are your ultramafic, mafic, intermediate, and felsic. So these rocks, if you bring them up, and then you can place them there and see these are your two dark rocks. And if you look very carefully, this one I can see crystals in it. These are going to be no crystals, but they have the same mineral because the color is from the minerals. One that formed very fast has a small crystals. So which minerals are going to be there? These minerals are going to be there making the rock dark. So that's what you write as your mineral product. Here you have the mineral olivine, so that's why it's making the rock green. Okay. So that's a little bit of what makes minerals, and what rocks are made up of. They're made up of minerals, and the colors of the minerals give the rock colors. Okay.